Imagine buying a first-class ticket because you trust that more money means more safety, more comfort, more margin for error. You settle into a private pod, a lie-flat bed, a crystal glass on the tray, a brand new entertainment screen glowing inches from your face. It feels like the safest place on the airplane. Because why wouldn't it be? This is where the airline spent the big money. But to make that comfort possible, engineers had run fresh bundles of wiring through the ceiling above the cockpit, threading them over shiny insulation blankets that every certification test had already signed off as safe enough. No passenger ever saw those wires. No one saw that insulation. Even the pilots, sitting just a few feet below, couldn't see what was happening above their heads. 50 minutes after Swissair Flight 111 left New York, cruising at 33,000 feet over the Atlantic, the first sign that anything was wrong wasn't a bang or a jolt. It was a faint chemical smell in the cockpit. Then a thin gray haze. Then smoke so thick the glow of the instruments turned the air in front of the pilots into a dull orange fog. They did what they had been trained to do. They ran the checklists. They turned toward Halifax. They started dumping fuel, convinced they still had time to get the airplane on the ground. What they didn't know was that a fire, fed by those hidden wires and flammable insulation above them, was already eating into the systems they needed to see, to talk, and to fly the jet. The people in first class never realized that the upgrade they'd paid extra for was part of the chain that would seal their fate. This is the story of the upgrade no one saw, and how it helped bring down Swissair Flight 111. On the 2nd of September, 1998, Swissair Flight 111 departed New York's John F. Kennedy International Airport at 8:18 in the evening, local time, bound for Geneva, Switzerland. The aircraft was a McDonnell Douglas MD-11. It was carrying 215 passengers and 14 crew members, 229 people in total. The plane had been delivered in 1991. Up front in the premium cabins, Swissair had installed an advanced in-flight entertainment system, giving first and business class passengers their own individual screens, long before that was standard on any airline. Weather along the route was ordinary. No major storms, no significant turbulence, nothing that would stand out in a pilot's memory. At about 58 minutes past midnight, UTC, the crew checked in with Moncton Area Control Center over Canada, reporting they were at flight level 330, about 33,000 feet, heading northeast off the coast of Nova Scotia. In first class, people settled deeper into their seats, selecting movies from that premium entertainment system. Real cutlery, real glassware. Up front, the captain and first officer, both experienced, both simulator instructors on the MD-11, monitored the instruments and the dark ocean beneath them. Everything about this flight looked like another uneventful overnight crossing. At just past 10 minutes past 1 in the morning, UTC, about 53 minutes after departure, the pilots detected an unusual odor in the cockpit. They traced it to the air conditioning system, common enough in large jets. At first, they saw only a faint suggestion of smoke, and nothing unusual in the passenger cabin. For a moment, whatever they saw appeared to fade. But by about 13 minutes past 1, they assessed that smoke was definitely present in the cockpit, even if the source wasn't obvious. At 14 minutes past 1, the crew made a pan-pan call to Moncton, reporting smoke in the cockpit and requesting an immediate turn toward a convenient airport. They initially named Boston, about 300 nautical miles behind them. The controller cleared them to turn toward Boston and begin descending. But within a minute, he suggested Halifax, only about 56 nautical miles away, as a much closer option. The crew agreed. They turned toward Halifax, descending, and pulled on their oxygen masks. At that point, they were dealing with a problem that seemed serious but manageable. Smoke, likely from air conditioning or electrical equipment, but no alarms screaming, no obvious structural damage. What none of them could know was that the real fire was not in the air conditioning system. It was above and behind them, burning silently in the ceiling space over the cockpit. The space above the cockpit ceiling on the MD-11, what mechanics called the attic, was packed with wiring bundles, ducts, and insulation blankets. A nylon smoke barrier separated the cockpit from the forward cabin. In Swissair's configuration, additional wiring for the entertainment system ran through this area, routed alongside thermal acoustic insulation blankets coated in a metallic plastic film. After recovering and reconstructing nearly the entire aircraft from the ocean floor, investigators found evidence of electrical arcing on wires associated with that entertainment system. They concluded that an arc, essentially a small but intensely hot electrical spark, likely ignited the insulation and nearby materials above the cockpit ceiling. A fire had started in a space with no smoke detectors, no fire extinguishers, and no line of sight from the flight deck. As the crew worked through their checklists, the fire spread along the insulation blankets, damaging wiring, melting plastic components, and producing thick smoke that pushed past gaps in the smoke barrier and into the cockpit. When they switched off certain electrical buses, a standard checklist step meant to isolate non-essential systems, it altered the aircraft's electrical setup, but it could not stop a fire already burning in the attic. Inside that unseen space, the upgrade that had seemed like nothing more than a seatback screen had become part of an uncontrolled fire path running directly above the pilots' heads. At around 16.5 minutes past 1 in the morning, UTC, Air Traffic Control, cleared Swissair 111 to descend to 10,000 feet and asked for the number of people on board and the amount of fuel. The crew asked the controller to stand by while they managed the descent. By about 19.5 minutes past 1, descending through around 21,000 feet and roughly 30 nautical miles from Halifax, the controller offered a straight-in approach to runway 06, but the pilots needed more distance to lose altitude safely. At around 20 minutes past 1, the crew agreed to dump fuel to get closer to their maximum safe landing weight and reduce the risk of an overweight landing. From the outside, it's tempting to ask why they didn't just head straight in and land heavy, but investigators later concluded that, given what the crew knew at each moment, their decisions were consistent with their training. At 23 minutes and 45 seconds past 1 in the morning, UTC, certain electrical systems were switched off. Just seconds later, the second autopilot disengaged, and the flight data recorder began capturing a rapid succession of system failures. Electrical buses dropped offline. Instruments and displays began failing. Alarms and chimes layered over the already desperate job of flying manually through smoke and darkness over the Atlantic. At about 24 minutes and 40 seconds past 1, both pilots almost simultaneously declared an emergency. Seconds after that, they told the controller they were dumping fuel and needed to land immediately. Just moments later, the recorders captured their last data. Radio contact with Swissair 111 ceased. At 31 minutes and 18 seconds past 1 in the morning, UTC, seismographic recorders in Halifax and Moncton, registered a seismic event consistent with an aircraft striking the water. Witnesses along St. Margaret's Bay reported hearing a low-flying aircraft, then a loud clap, then silence. Swissair 111 had struck the Atlantic Ocean about 5 nautical miles southwest of Peggy's Cove, Nova Scotia. In darkness, descending, uncontrolled, with catastrophic fire damage throughout the aircraft. The plane broke apart on impact. There were no survivors. Debris sank to a depth of about 55 meters, scattering across the seabed. Smaller pieces washed ashore along the rocky Nova Scotia coastline. For local fishing communities and volunteers, The recovery effort became a months-long ordeal, retrieving wreckage and remains under floodlights, in cold wind, under the weight of global scrutiny. Families in Switzerland, the United States, and around the world learned the news in fragments. First, that there was smoke, then that the plane was missing, finally, that there were no survivors. Memorials were later built at Peggy's Cove and Bayswater, looking out over the same dark water where the MD-11 had disappeared. Canada's Transportation Safety Board launched an investigation that would last 4.5 years, eventually producing a 338-page report. The effort cost around $39 million. Investigators recovered nearly the entire aircraft by weight from the ocean floor, including roughly 60% of the forward fuselage, which was painstakingly reconstructed inside a hangar. The forensic challenge was enormous. Identify where the fire started, how it spread, and which systems failed first, using only scorched fragments of wiring, insulation, and structure pulled from the seabed. Investigators found evidence of electrical arcing in multiple locations. But one area stood out: wiring associated with the in-flight entertainment network, running through the attic above the cockpit and forward galley. They also found that the metallic-coated insulation blankets in that area had sustained extensive fire damage, meaning those materials hadn't just been exposed to fire, they had helped it spread. Laboratory tests confirmed it. Some of those insulation materials could ignite and burn vigorously when exposed to even a relatively small electrical spark. The final report concluded that the crash resulted from an in-flight fire that began above the cockpit ceiling near the forward galley, most likely ignited by electrical arcing and wiring associated with the entertainment system. Once that fire took hold, it spread rapidly through flammable insulation, damaged critical systems, and eventually destroyed the instruments, the communications, and the crew's ability to control the aircraft. Importantly, the board did not assign any fault to the crew. The pilots were confronted with a hidden, fast-developing fire in a space where the detection systems, the training, and the certification standards of the day were simply not enough to save them. Swissair Flight 111 exposed deep gaps in how the aviation industry thought about hidden fires, flammable materials, and the supplemental systems being added to aircraft. One of the central findings was that flammability standards had allowed certain insulation materials to pass certification tests that simply didn't reflect real-world fire conditions inside an airplane. In a lab, they passed. In an attic full of electrical wiring, they burn. In response, aviation regulators, including the FAA, moved to ban those metallic-coated insulation blankets from transport category aircraft. Airlines were required to remove and replace them with materials that met stricter, more realistic fire tests. New test methods were introduced to evaluate how materials behave when exposed to radiant heat and electrical faults in enclosed spaces, not just a small flame held to a small sample in an open room. The accident also forced a rethink of how wiring is installed, particularly for supplemental systems like entertainment networks. Regulators tightened requirements for how wires are routed, bundled, protected from wear, and inspected, especially when they run near flammable materials or critical systems. Another major lesson came from that hidden attic space itself. The TSB recommended better smoke detection in overhead and concealed areas, improved cockpit firefighting procedures, and a broader awareness that electrical smoke can originate in spaces a checklist step alone cannot reach. The crash also highlighted a painful limitation: flight recorders that go silent when the aircraft loses electrical power. Safety advocates pushed for recorders with independent power supplies so that even if the main electrical system fails, investigators can still piece together the final minutes. And beyond the hardware, Swissair 111 changed how countries respond to aviation disasters. Canadian officials and volunteer organizations documented hard lessons about communicating with families, providing mental health support, and coordinating large-scale recovery efforts. lessons that shaped responses to other mass casualty events that followed. Today, many passengers will never know that the insulation behind their cabin walls or the wiring above their heads is different because of this one flight. But the materials, the routing rules, and the detection systems now in place carry a trace of Swissair 111 in every engineering drawing that says no to flammable blankets in hidden spaces. For the 229 people on board Swissair Flight 111, the story ended in less than 21 minutes. From the first unusual smell to impact with the ocean. For their families, and for the communities along the Nova Scotia coast, the story has continued. In memorials, in anniversaries, in the empty spaces left behind. It's a story that starts with trust. Trust that more money buys more safety, that certified materials really are safe, that every wire added to a complex machine has been imagined in failure as well as in normal operation. On that night in 1998, those assumptions failed. But aviation is built on the idea that no catastrophe is allowed to pass without being turned into knowledge. From the wreckage of Swissair 111 came new rules about what can burn inside an airplane, new scrutiny of every upgrade installed above our heads, new tools for detecting the fires we can't see until it's too late. Passengers boarding a long-haul flight today may never hear the name Swissair 111. Yet every time a hidden wire is protected, every time a flammable material is rejected in testing, and every time a pilot treats smoke as a race against an unseen fire, a small part of this flight is still at work, silently pulling the risk back down. The upgrade no one saw cost 229 lives. The lessons drawn from it are now woven, quietly, invisibly, into the safety of every modern airliner crossing the Atlantic at night.